Good evening, everybody. Welcome to night 4 of Lambda School's mini bootcamp. My name is Deandra Ryan Moss. I'm an instructor at Lambda School, and I am teaching you guys live from Bisbee, Arizona tonight. So thank you all for joining me. For everyone who's live, I hope you're in Slack and prepared to interact and ask questions. And for anyone who's watching the video later, that's cool too. That's why we put them up. So before I jump into any coding or any review of what we did last night, I want to tell you a little bit about Lambda School and about this mini bootcamp for anyone who is just joining us for the first time. And if you are joining us for the first time, we are on night 2 of JavaScript. So if you're a JavaScript beginner, you might want to roll back and watch the video from last night first, but you're absolutely welcome to come in midway and review stuff from before. So yeah, let me jump in and tell you a little bit about Lambda School though. So Lambda School is a full-time computer science immersive. So it's a 6-month full-time program where we teach you how to program. So we teach you web development topics, everything from front-end web development, HTML, CSS, some CSS frameworks, preprocessors, everything you need to do the design aspect. We also move into front-end JavaScript and then into back-end JavaScript. So including frameworks on both of those. So we teach React and Node. So by the end of the course, you are a full stack developer. And even beyond web development and the related frameworks, we also try to round you out and turn you into a really computer savvy, computer sciencey web developer. So we also teach some more CS topics. So we teach Python and some object-oriented programming, which will help you think about algorithms and the more academic side of things. So we really focus a lot on the practical day-to-day skills you need as a web developer, but then we also round it out with some other related skills to make you guys really ready for the job force. And speaking of being ready for the job force, one cool thing that Lambda School does is that we do not charge you anything upfront. So we feel so confident that you are going to be ready for that job when you're out of our program that we actually allow you to wait and pay us back after you have gotten a job. So you only pay us if you get a 50K or more web development or programming job. So if you don't get the job, we don't get paid. So we're very motivated to get you out there. Lambda School is entirely online. And so I know a lot of prospective students wonder, what does the teaching environment actually look like being online? And we try to keep it really dynamic and a blend of interactive as well as self-driven. So quite similar to this boot camp, there is a blend of live instruction, there's question and answer sessions, there's time to work solo on your projects, and then there's time to come together in groups and work on projects with other students. So it really is a blend of a lot of different things. And your day is a full-time program, so you are working 8-9 hours a day, but we leave time for you during that period to work on homework. So it's not something that's going to be carrying over outside of class. So we allocate time throughout the program to get everything you need done. So that is Lambda School for you. If you are interested in applying, please reach out to Karen Zachary. If you have questions about applying, reach out to her as well. And as a note, you don't actually have to finish this bootcamp to apply. So if you feel ready to start that process, reach out. So let's talk a little bit about what this bootcamp is. So it is a 2-week intro to web development course. So earlier this week, we learned a little bit about HTML and CSS, and now we've moved on into JavaScript. So for today and all of next week, we are going to be learning the basics of JavaScript to get you guys ready to apply that to web development. And without any more chit chat, let's go ahead and do some JavaScript. So I am going to share my screen and then we'll review a little bit of what we saw last night and dive into some new topics. So at the very end of last night's lecture, I introduced you to this idea of control flow, which is that at first glance, it appears that JavaScript executes each line in order exactly as you'd think, but there's actually a lot of tools built into JavaScript that allow us to skip chunks of code or move them around, or as we'll see tonight, repeat lines of code. And that's one of the things that makes JavaScript a really dynamic language. So we're going to dive even deeper into control flow tonight. And by the end, you will be if-else masters, and you will also learn a little bit about looping. So let me share my screen and we can get started. Okay, so I'm up here in Replit. As we've been going over this whole week, Replit is a sandbox environment. So it's a place where we can write JavaScript code, run it, and pretty easily see what's going on. So I know there was a bit of confusion in the Q&A last night about when we run code in Replit, what do we see over here? And I will review some of that today as we're going along. But first, I just want to talk about variable declaration and types of objects and data types in JavaScript. So we were introduced last night to some of the most basic types in JavaScript, or primitive types. We have things like strings. Second. Okay, there we go. Replit was being non-responsive. So we have things like strings, which is just text. It can be a single word, it can be an entire paragraph, an entire sentence, or it could even be a blank string if we wanted. We can tell we're working with a string because strings are always between quotes. They can be in single quotes or double quotes. Though if you try and mix and match a single and double quote, you might get an error. So those are strings for you. We also have numbers. Pretty basic. You just type some numbers. Numbers are great because we can combine them, use mathematical operations. We can also use math object to do a slightly more advanced thing with numbers. But yeah, so numbers, another primitive type. And just to clarify, if we have 2 in quotes, that is actually a string. That is the string that contains the number 2, not a number. But if we have 2 without quotes, that's a number. The next data type I want to review is Booleans. Booleans are either true or false. If you type out true or false, you have a Boolean. Once again, if you type out true in quotes, that is no longer a Boolean, that is a string. The other basic types that we went over at the very end were undefined and null. So we have null, which is just the word null, and undefined. And both of these signify that essentially the data is missing. So for example, if we declare a variable, don't set it equal to anything, variable will be undefined. We can also explicitly set something equal to null or undefined if we want to signify that there's no content. On the subject of declaring variables, I also wanted to go over that. There are a couple variable declaration keywords. The one that is used most often is going to be const. So if we have const age equals 6, that means that we have taken the number 6 and created a variable called age and then saved that value into age. So we can pull up that variable later in our code and retrieve the value. Because we use const, age is a constant, which means that we cannot change the value of age at any point. Of course, if we want a bit of code that we might continue to use dynamically over years, we would want to change age. So in that case, we would probably use the keyword let. So same as with const, we have created a variable called age, and we have stored this number in it. The difference is that now if we want to change that value and set age equal to 7, for example, we're allowed to do that. So age can be updated. If instead I had used const here, we would get an error for trying to change the value. So in this case, we would want to use let. The final variable declaration keyword is var. And so var is from ES5, an older version of JavaScript. It still is around because JavaScript always has to be backwards compatible, which is to say that we don't want to upgrade our JavaScript and then have the entire internet break because we got rid of things. So generally, things in JavaScript never disappear. We just add better versions. So var isn't often used anymore. We usually use const in the case of an unmutable variable, something we don't ever want to change, or let if we want to be able to change it. I know we had some questions about the difference between let and var last night, and I will let you know that in just a moment here, as we move on into some of the topics for tonight, I'll explain in a little more detail one of the other things that makes let cool and interesting. So the last thing that I wanted to review, actually there are a couple more things I wanted to review. The next one is the plus plus and minus minus operators. So I showed these to you last night, which is that if we want to use the plus plus operator on a number, it will increment the value. So whereas before I explicitly said, let's change age to 7, but this time I did plus plus, which means whatever the value of age is, increment it. So in this case, it becomes 7. But if this were 10, it would become 11. One little subtlety about plus plus that I didn't go over last night, which is that this line of code actually resolves to the original value of age. So line 2, even though we're incrementing behind the scenes, at this moment in time, age is still equal to 10. However, on the next line, age will be equal to 11. The same thing happens with our minus minus operator. As you might imagine, this does the opposite. It decreases the value of age. So on this line, age is still equal to 10, but by line 3, it's going to be equal to 9. So that's a little bit of a subtle point, and it goes back to this idea of code resolving. So this was something I kept bringing up last night, and it's a difficult concept to get, but becomes really important if we want a nuanced understanding of JavaScript, which is that every line of code resolves to something. So this first variable declaration statement, as we know, it creates a variable and stores a value in it, which is something that happens in memory. But this line of code itself doesn't resolve to anything. So when I run it, we see over here in green, undefined, because this line of code didn't resolve to anything. If instead I retrieve that variable, now this bit of code resolves to something. Of course, I could store this somewhere in a different variable. Now this line of code has an effect in memory. We've created a new variable and put a value in it, but this line of code doesn't resolve to anything. So this is an idea we will keep coming back to tonight and all next week, which is what does the code actually resolve to? So this piece resolves to 10, but the entire line doesn't resolve to anything. So that's why we see undefined over here. So the very last thing I want to review is if-else statements, which we will see a lot of tonight. So generally speaking, when we just write out lines of code, the code will run from top to bottom, and every line of code will be run. So that's kind of the basic understanding of JavaScript. But often we want to do something more subtle. So for example, if we had a Boolean called add, we could say if add, which means if add is true, then let's go ahead and console log x plus y. Otherwise, maybe instead we want to console log x minus y. And as a reminder, a console log is console is a global object, and .log is a method on that object. And the effect of the entire thing is that we are allowed to log things out to the console. As a reminder, the console is a little built-in sidebar that we have over here that allows developers to give feedback to other developers or to themselves. Within Replit, the console appears in white over here. So here we see that because add was true, this if block executed. So line 6 executed, but line 8 was skipped. If instead add was false, then the if statement would be skipped and the else would execute instead. So using if-else statements or just if statements, we can specify, okay, in some cases we want some bit of code to execute, and in other cases we might want it to behave differently. That way, if this variable might be different depending on user input or some other conditions, and we could have a dynamic piece of code that behaves in subtle ways based on input. So if-else statements are all part of this idea of control flow, which is subtly affecting which lines of code run at which moments and why. And that's pretty much what we're going to see tonight. So that is a little bit of a review of everything or most of what we saw last night, condensed quite quickly. Hopefully you guys got plenty of practice on the homework and are feeling mostly good about the concepts from last night. So the first new concept I want to add is something called scope. And scope is, once again, a bit of a subtle concept, but I think that it's good to start to think about it from the get-go. And we've already kind of seen scope without actually calling that. So I'm going to go ahead and get rid of the else block and just look at this if statement. So as we know, everything in between these curly brackets are part of the if block. And what that means literally is that if the if condition is true, everything in here will execute. Right now, I just have one line of code in there, but there might be 10 or 20 or 50 or 100 lines of code in here. There could be a whole complex set of instructions in here that only execute sometimes. And that is called the if block. We can visually tell where the if block starts and ends using the curly braces. And conceptually, we can think about the if block as being everything that executes if the condition is met. So it turns out that everything inside of these curly brackets have something called scope. Everything out here on the outside also has scope. We would call this the global scope. So when we declare this variable, we're declaring it within the global scope. Same with this one, etc. And that means that no matter where we are in the code, we can access that. So the global scope is, as it sounds, global. So anything that exists in the global scope can be accessed within the if scope. We can see that in practice here because I was able to access both X and Y from the global scope within the if block. However, the opposite is not always true. And that is one of the subtle pieces of the variable let. So if I create a variable and let's say, call it z and say let z equals x plus y, and then we'll log z instead. So right now, what I've done is I've pretty much just accomplished the same task, but in 2 lines. Instead of logging x plus y directly, I'm saving them in the z variable and then logging that. And we can see that the code still runs as expected. But notice what happens if we try to access z from outside of the if block. We get reference error. Z is not defined. And that's because whenever we use let within a block scope, so for example, within an if statement or within an else statement, z exists as long as the curly brackets are there. But once we finish the end of the curly bracket, once we're out of that scope, z does not exist. So if instead I had declared z out here, now it exists in global scope, which means that we can access it within the if block or outside of it. But if we create it within the block, then once these curly brackets are done, it's like this variable never existed. So that's another subtle piece of let. If we used var instead, we don't see that happening. There's none of that scope subtlety. So one of the reasons I'm showing you this is to let you know a little, to kind of more fully answer a question from yesterday that went unanswered, which is, what is the difference between let and var? The other reason I'm telling you this is to get you familiar with this term scope and this idea of when we start the curly brackets for an if or for some other things, slightly different rules apply. And you're going to see some other examples of how that applies to loops and as we go along, things like functions as well. So that's a little introduction to this idea of scope. And as mentioned, scope is a pretty big and subtle topic in JavaScript. So this is just kind of a beginning glance at what is scope and how does it work. So let's move on to some other topics that are relevant to if statements, which are comparison operators. So I showed you a couple of comparison operators last night. So first of all, I showed you that you can compare things using less than, greater than, less than, equal to, etc. So let's review those really quick. So let's say that I want to write a bit of code that subtracts Okay, so I want to create a little bit of code that subtracts two variables, but I don't ever want to get a negative number. So in this case, what I'm doing is I'm first checking, is x greater than y? If so, then I'm going to subtract them and log the result. But if we change these values so that y was larger, then the if statement would be skipped. As well, notice that if they're equal, it won't run because we're specifically saying, is x bigger than y? If we wanted to include cases where they were the same, we could add the equals for greater than or equals to y. And in that case, now the if statement executes. Of course, if we wanted to do the opposite and only have this code run if the subtracted value was negative, we could swap this and only run it if x is smaller than y. So takeaways here are, first of all, that we have things called comparison operators, and they're ways that we can combine two different numbers to get a Boolean. So down here, we can really combine any set of two numbers with a comparison operator, and it will always resolve in a Boolean. In this case, false, because 3 is not greater than or equal to 10. And beyond just being able to compare values, we can go ahead and toss those directly in our if statement. So our condition can be some sort of comparison. And these comparisons work for numbers. So one more comparison that I didn't introduce you to last night was the equals. So it's tempting for new developers to use a single equal sign because that makes complete intuitive sense. And in fact, I had one student messaging me last night because he was trying to do this and was curious why it didn't work. So this will give you an error. And the reason is that in JavaScript, the single equal sign is used for assignment. So when we declare a new variable, we always use a single equal sign, or even when we put a new value in a variable that's already been declared, single equal sign. And we want to make sure that we're being completely clear about what we're doing. So we wouldn't want to use the same symbol for comparisons. So instead, we use triple equals. So this will tell us if the two values are equal. So in this case, let me get rid of my if block for a moment. In this case, of course, they are not equal, so we get false. If I did 10 triple equals 10, we would get true. And the triple equals works for all types of values. So we can compare strings, and see that they're false if they're not equal, and true if they are. We can even compare different types. So we could compare a Boolean to a string. Of course, that's always going to be false. One thing I do want to mention about the triple equals is that this is the symbol that we want to use for comparisons as beginning developers. There is also a double equals, though. And most of the time, it's going to work the same. The difference between the double equals and the triple equals is triple equals wants things to be precisely equal. So for example, if I did undefined triple equals null, that's going to be false because undefined and null are different. They're similar, but they're different. However, the double equals will give you true. So the double equals is more of a, are they almost the same? And it's not something you want to use until you're really comfortable with what are the cases when this is going to give me true or false. For beginning developers, most often the double equals means that there is going to be an error in your code. So start off with the triple equals. You can do some research on the double equals if you're interested, and start to work that in as you become a more sophisticated developer. But for now, I would start with the triple equals when you want to check if two things are equal or not. So those are the most basic comparison operators. And as we saw, they're often used in if-else statements. So we could do if x equals y, console log. So in this case, nothing is logged. But if we change those variables to be equal, then our if block would run. So those are logical operators. Those are comparison operators. The next thing I want to talk about is the idea of truthiness. This is another subtle way that we can use if statements. So let me just put together a little if-else statement. So this thing is going to do the most obvious thing in the world, which is if it's true, if the condition is met, it will log if, otherwise it will log else. So of course we can put any sort of Boolean in here, whether we explicitly put in a Boolean or we could put in a variable that's set equal to a Boolean, or we could put something like a comparison, which resolves to be a Boolean. So Booleans are most certainly allowed in an if statement, but we can also have a little bit of leeway with this. So every single variable in JavaScript is either truthy or falsy. Yes, you heard me correctly, truthy or falsy. And which I think when you hear that for the first time, most people's reaction is, it sounds like you're making something up. But no, it's literally called truthy or falsy. And that means that every variable is either considered true or false by the standards of an if statement. So, for example, x is not a Boolean. It is most certainly not a Boolean. It is a number. But we could still put x as our condition in an if statement. And as we see, the if part runs. That means that x is truthy. If I change this to -2, it would still be truthy. And in fact, almost every single number is truthy except for one, 0. So 0 is considered falsy. That means that if we try to resolve it like a Boolean, so if we put it in an if block, it will be considered false. So every single number is going to be considered truthy except for 0, which is falsy. There's something similar that happens with strings. So if I have a string and I put that in here, it will almost always be considered truthy. So whatever I put in here, even if it's just a garble of symbols, it's going to be considered truthy or considered true. The only string that is falsy is the empty string. If we put an empty string in an if block, the else statement will trigger. So you're probably seeing a pattern, which is that most variables are considered truthy. But if there's sort of this sense of missing content, such as a 0 or an empty string, then it's considered falsy. So you might have guessed two other falsy data types, which are null and undefined. So both null and undefined are considered falsy. So the reason for this falsy truthy thing is it actually turns out it's really useful in a lot of cases. And the case that it most often comes up in is when you're trying to say, is the data there or not? So for example, if a variable is undefined, you might want to execute one thing, and if it's defined otherwise, do something else. So let me show you an example of that. So if I have let address equal blank, I might do if address. So maybe here you're executing some sort of logic where you send a letter. For now, I'll just do a console log. Otherwise, maybe you want to do, actually, I'll use console.error, except console.error doesn't do anything interesting in Replit, unfortunately. So maybe you want to do address not found. So in this case, if address is an empty string, or if it's set to null, or if it's even not defined at all, we see that address not found executes. Of course, this isn't a perfect system, because if the address were incomplete or something like, just a number and a street without a full address, it wouldn't be subtle enough to tell that. But in a lot of cases, we really just care, is the data missing? And that's a place where we might use this truthy and falsy property in order to check, in order to determine which bit of code we want to execute. So that is the concept of truthy and falsy. So every single variable in JavaScript is truthy or falsy, which means that an if statement will either treat it as true or treat it as false. Most things are going to be truthy, but if the data is missing in some way, such as empty strings or zeros or null or undefined, then it's going to be falsy instead. All right. Oh, we have a little bit of a chat going on in Slack about the not equals. So yeah, I will go ahead and go over that now. I was going to introduce not a little later, but I think this is a good time to bring that up. So there's also a not equals operator, which is an exclamation point and 2 equal signs. So if we have string 1 and string 2, we can see that those are not equal. So this one can be a little confusing because remember it's reversed. So if they aren't equal, then we get true. But if they are equal, then we get false. And it is true that you could do the single equal not. This is kind of like the reverse of the double equals. So once again, I would stay away from this one until you're a little bit more experienced and have a sense of the rules of double equals. So just like we want to stick with the triple equals for now, we want to stick with the triple equals version of not equals. So once again, this is something that we could put into an if block because it resolves to true or false. All right, so that is the not equals comparison operator. All right, let's move on to logical operators. So the very first logical operator I wanted to show you was actually not, which you've gotten a little bit of exposure to just a moment ago. So logical operators, whereas comparison operators are ways of comparing 2 different data types and getting Booleans, logical operators are ways of combining Booleans themselves. So the first one is not, and it does exactly what you would think. So if you do not true, that's going to be false. If you do not false and spell false correctly, that's going to be true. But you can make things more complicated. So you could do not and then maybe compare 2 numbers. So 2 is less than 4, which means that everything in the parentheses is true. But then we put a not on the outside, which makes everything false. So this is where this logic stuff can be a little confusing. So first we think about, okay, everything in the parentheses is true, but then we not it, so it becomes false. Now, if we reverse this, it would become true because it's the opposite of this statement. So that is the not. And nots do something pretty cool with truthy and falsy values, which is that if you do, if you ever do not of a truthy value, you get false. So not of a string with content in it, also going to be false. Not of any number will be false, except of course 0. So because 0 is falsy, if we do the opposite of it, we get true. So if you ever want to turn a falsy value into a Boolean, and you do the not operator, you get the opposite thing. But check this out. This is a really useful tool. So if you do not, of course, if you start with a Boolean and do double nots, it just flips it twice and you're back where you started. So doing a double negation on a Boolean is kind of a waste of time. But if you do a double negation on a falsy value, like an empty string, then it turns that into a Boolean. So if you want to take something that's falsy, like null or a blank string, and turn it into the value false, you can use the double not to do that. Same thing goes with something that's truthy. So if you want to take something truthy and turn it into just the value true, you can use the double equal sign to do that. So useful tool, because sometimes you need an actual Boolean value. And in that case, this double not works really well to get you your result. So the first logical operator we learned is the not symbol. The next one I want to show you is or. So let's say if has car, let's set that equal to true. Has bike, let's say has bike is false. And then maybe we have a variable that's can get to the party. Kind of a long variable name, but maybe can get to party. So let's say that we're trying to get to a party and it's a bit too far to walk, but you know, it's still pretty close. So it's in biking distance and it's certainly in driving distance. So we would say that if you have a car or if you have a bike, you can get to the party. So that would be an or scenario. So the symbol for or is two of these little pipes. So we would say has car or has bike. And that will give us this can get to party value. So in this case, we have a car, but we do not have a bike, so we can get to the party. Of course, if it were reversed, if we did not have a car, but we did have a bike, we would still be able to get to the party. The last thing I want to mention is, let's say that we have a car and a bike. Well, in this case, we certainly can still get to the party. We, in fact, can choose what our mode of transportation is. So this is still true. So the or is inclusive. If either one of these is true, or if both of them are true, and we use the or operator to combine them, the result is going to be true. However, if we do not have a car and we do not have a bike, then we can't get to the party. So the only way to get a false value out of an or statement is if both of these are false. So that is an or statement. This is another comparison operator, but it's a little different because we're now comparing two different Booleans. So we would refer to it as a logical operator because we're taking two different logic statements, two different Booleans, and combining them to get another Boolean. One little note I want to say is that or is two pipes, not one. So that's easy to forget at the beginning. But yeah, two of these little pipe symbols. And we have or. So the next one I want to show you is and. So let's say the party is so far that we definitely have to drive, and it's also a potluck. And we're good party guests, so we're not going to show up to a potluck unless we bring something, right? We don't want to be that guy. So in this case, we would want to use and. So has car and made food. So in this case, both of these need to be true. We're only, or let's say can go to party, sorry. So if we have a car, then we can get there. And if we made food, then they'll let us in. So we need both of these to be true to go to the party. So in this case, we do have a car, but we didn't make any food. So we see that can go to party is false because one of these is not true. If we reverse them, if we said we don't have a car, but we did make food, then we'd be welcome, but we can't get there. So once again, we can't go. And of course, if we don't have a car and we didn't make food, there's definitely no way we can go. But if they're both true, if we have a way to get there and if we have some food to bring, then we can go to the party. So and becomes true only if both of these are true. So if either or both of these are false, and becomes false. So and is a little bit more strict than or. In the case of or, we only need one to be true, or both. But in the case of and, both definitely have to be true. So that is and or. They're pretty simple concepts, but they definitely take a little bit of practice to do. So there's a lot of opportunity to practice these tonight. The next thing I want to mention is that things can get a little complicated because we can use and, we can use or, we can use not, but we can also use all of them combined. So for example, if we wanted to change this to, let's do cannot go to party. now we might do this instead. So this is a little confusing, right? Because first of all, this is kind of a confusing variable name. But what we're doing here is we're saying, okay, are either of these true? All right, now let's reverse that result. So let me come up with a slightly better example to show where chaining these might work. So let's say, actually, let's combine the last two examples. So if we have has car, has bike, and made food. So we'll say we have a car, we do not have a bike, but we did make food. And then we want can go to party, and we'll see what that is equal to at the end. So the idea here is that we need a car or a bike, either one will do, but we definitely need food. So we would start out by saying, okay, if we have a car or if we have a bike, then we know we have transportation, but we also need food. So in this case, we're saying, okay, either of these has to be true, and then the result of that and the result of this also need to be true. So in this case, it works because we have one of the modes of transportation and we have the food. But if we flipped this, if we had both modes of transportation, but we didn't make food, it wouldn't matter. We still can't go to the party because, yes, we have options on how to get there, but it doesn't matter if we didn't make any food. So we can start to throw in nots all over the place and make things really confusing. These things can chain up and they can get quite confusing. And it does take a lot of practice to get used to how to putting all these together. To be fair, this is a pretty bad piece of code. This is definitely not the simplest way you could write this statement. But on the homework tonight, there's going to be ample opportunity to practice combining these logical operators. So it really does just take a little bit of practice to get used to them. But that's the gist of it, is we have or, and not. So moving on, and of course, we can use these in an if statement. So sometimes you'll see them stored into a variable. Sometimes you might actually write in and made food. So you can also write in the logical operator directly into the if statement if you want. So if we set that to true, now our if statement will trigger. So these definitely have applications in if statements. And oftentimes when you see ors and ands, it's in the context of trying to figure out if a certain bit of code should execute or not. All right, so the last thing I wanted to show you with if statements is something called an if else. So as you probably noticed, our if statements so far are specific to two scenarios, right? Either we get the if or the else. We'll do else. We're disappointed, so we'll do a disappointed all. Also, a little side note, if we're ever using quotes inside a string, we just use this little backslash symbol. That's just saying, that's our way of telling the code, hey, we're not trying to end our string. We just want this actually to be a symbol within our string. So if this becomes false, we get the I can't go statement instead. All right, so in this case, with the if-else statement, we have two options. Either we can go to the party or we can't. But let's say that we wanted three statements. We want, in some cases, to say party on. In another case, we want to say, I forgot to make food. And maybe in a different case, we want to say, I can't get there. So how would that look? Well, we can't do a separate, we could just do a bunch of separate if statements, but what's more subtle is to do an else if statement. So we say, if we have a car and we made food, actually, let me do it this way. Sorry, 1 second. So let's start with made food. So let's say we didn't make food. So we'd want to use our we did not make food. In that case, we want to console log I forgot to make food. Now let's do else if. So else if still requires a logical thing. So else if we do not, let's say we do not have a bike and we do not have a car. So if we don't have a bike and we don't have a car, then we can't get there. Otherwise, we can go to the party. So right now, we didn't make food. So the first statement is going to trigger. And let me add some spaces in here to make this a little clearer. So in this case, we did not make food. So the first if statement executes and we log this. However, if this statement is true, but it turns out that we don't have transportation, we're going to skip the first if statement and move on to the else if statement. Now, because both of these are false, we know that we need a ride. However, if we have transportation and we made food, then we default to this else statement. And only one of these three will run. So look at this. If all of these are false, then it's true that we forgot to make food and it's true that we need a ride, but only the first will execute. So once one executes, the rest will be ignored. So that's the difference between an else if and just starting a new statement over. So on an else if, we're allowed to actually come up with multiple conditions, but only one will ever be executed. So that is an if else statement, which is a slightly more subtle version of the if else. So once again, it is else if, and else ifs require another logical statement. So there you go. That is the deep dive version of if statements, which were introduced last night. So there are a couple more topics I want to cover tonight with respect to control flow. And that, well, actually just one topic, but a couple things to say about it, which is looping. So if else statements or if statements are great when we want certain bits of code to run sometimes and other bits of code to run other times. But sometimes we want the same bit of code to run a bunch in a row. So let's say that we were trying to do some sort of countdown. We could console log 5, 4, 3. I'm already getting sick of writing out all these console logs. And then the last one. So that kind of sucked, right? I had to, even though they're slightly different bits of code, I had to write them like 6 different lines of code that were almost the same. And that's really tedious and a waste of my time and kind of a waste of space on the screen. So this is an example of where you might use looping. Sometimes you might even want to do something more explicit, like say you wanted to log the same thing a bunch of times in a row. For some reason, you have a piece of code that just needs to run hey 4 times. Once again, we could copy and paste, but that's a big waste of time. And this is my first opportunity to introduce you to this idea of dry coding. And I will bring this up a lot. So dry stands for don't repeat yourself. So why don't we want to repeat ourselves? Well, first of all, it's a waste of time. Second of all, let's say that I wanted to change this to hello. I would have to change it in 4 different spots. And that's not good. We want to keep things condensed, so if we need to change them, we can just change them in one spot. So that, and another thing is if we want to edit it, it's kind of like, where is it coming from? Which console log is it? So don't repeat yourself. Good rule of thumb for coding. So how do we prevent this from happening, these 4 lines of code that are identical? With looping. So let's write our first for loop. I'm going to write it out, and then I'm going to break down in detail what it actually does. So let's do this. And inside of this, I will do hey. So now in much less code, the same thing has happened. I've said hey 4 times. And if instead I wanted to say hey 16 times, I would just have to change one thing, and now this thing is saying hey 16 different times. So that is a for loop. Really useful tool for not having to repeat yourself. So let me break down what this thing is doing. For starters, we want to use the keyword for, followed by a set of 3 different conditions. So kind of similar to the if statement in that we start with our keyword and then we have some conditions in here. Following the conditions, we have a couple curly brackets, and as you might imagine, we have some for loop scope inside here. So another example of scope. And I'll show you a few ways that that's relevant. So we have some for loop scope, and then in here, we have what we want to repeat. So this is the line of code that will be executed however many times. So in this case, I am executing this 16 times, and that is determined by these conditions up here. So let me break those down in detail. For starters, we need an index. So some sort of variable that will keep track of where we are in the loop. By default, you always want this index variable to be the letter I. And usually, you want to start it at 0. If there's no reason not to, just start it at 0. And you'll see this as kind of a computer science convention, is that we tend to start counting at 0. This will come up in a few different places. So we have to declare I, so we'll use let. And let is critical here because the value of I will be changing. So the first thing in this, the first condition is, all right, what's our starting place? So we declare a counter variable called I, and we give it a starting place of 0. Then we have a semicolon. So this will indicate that our next condition is being written. The next condition is when do we want to stop? Or more, when do we want to continue? So here we're saying continue this loop as long as I is less than 16. Or in other words, stop this loop once I is equal to 16. The final thing is, how do we want to change I every time? And we're using our friend the plus plus operator to say every single time, let's increment I by 1. So the first time this runs, this first hey, I is equal to 0. Then I is equal to 1. I is equal to 2 and 3, 4, etc. And then when we get up to I being equal to 15, that's our very last spot. So I is equal to 15 in the last spot because we started at 0. And then we swing around to try to do another loop, but we see that this condition is no longer true, so we stop. So that is a for loop for you. And if we want to be clear about when I is equal to what, we can console log I instead. And now if we run this, we see, just like I said, that I gets up to 15, and then it quits. If we wanted to go all the way up to 16, we could use less than or equal to. If we wanted to start at 1, we certainly could. If we wanted to start at 6, we also could. So we can definitely tweak these values around. As well, it doesn't always have to be plus plus. Say we want I to start at 10 and go down to 0. So as long as I is greater than or equal to 0. And in this case, we want to decrease it. So now we're counting down instead. So we start at 10. We want to stop once it's below 0. And then every time we want to decrease I. So we can do other things apart from plus plus and minus minus. Most often you'll see plus plus or minus minus here, but we could also do set I equal to I, let's say I minus 2. And now we're decreasing it by 2 every time. So there's a lot of different tweaking that we can do over here in terms of how our loop runs. But you'll find in most cases that you start at 0, stop at some value, and then do I plus plus. Most often this is the for loop that you are going to write. So there you go. That's a for loop for you. So a couple things about scope. So as we saw, scope affects let. So for example, if I want to see what I is equal to at the end, we know that I is not defined. And it's a little confusing here because we don't literally declare I in between the brackets, but everything in this condition statement also is in the for scope. So because we used let, I does not exist outside of the for loop. We could try const, but we would get into a lot of trouble because we're trying to increment I, and that doesn't work for a constant variable. So once we're done with our for loop, I doesn't exist anymore. And honestly, that's really nice. That's actually a feature of let, because really you don't want these random i's to be floating around and have value, because their only purpose is to keep track of your place as you loop. So another thing about scope that you haven't seen yet is that sometimes there are keywords that exist in a scope that don't exist elsewhere. One example is the continue or the break keyword. Oops. So both of these are JavaScript keywords that only exist in a for loop. So if I type continue out here, we get a syntax error. It says unsyntactical continue on line 9, because continues don't make any sense outside of a for loop. But let me show you what continue does. So let's say that we want to console log 0 through 5. So we have this loop that console log 0 through 5. But for some reason, we just hate the number 2. So we don't want 2 to appear. So what we could do is say, okay, if I is equal to 2, notice triples equal, I don't want it to log. So we could always do, if I is not equal to 2, then console log I. This would totally work, to be fair. So we're console logging every time that I is not equal to 2. But another way to do this would be to say, okay, if I is ever equal to 2, continue. That means continue the loop. It means that quit out of this section of the loop, but then continue it. So basically it's saying, okay, when I is equal to 2, let's just increment I and do the next one. Don't bother reading the rest of the code down here. That's what continue does. So it basically is for skipping one or more iterations of the loop, but it doesn't stop the loop in its tracks. That's what break does. Break is saying, okay, I hate the number 2 so much that I don't even want to keep looping. So we get up to 2 or up to 1, but then when we hit 2, we get a break statement which quits out of the loop. So those are 2 useful keywords that you can use to allow your loop to behave in slightly more subtle ways. Break will break off the loop at some point, and continue will just say, hey, let's skip this iteration, but keep going with the loop. So 2 more things I want to show you with loops before we're done. The first is they're both really words of warning about why you have to pay close attention to what your conditions are here. So let's say that I did, if I is less than -6. Actually, we'll do greater than -6. So as long as I is greater than -6, keep going. So what's going to happen? Well, we just had an infinite loop. That's because we started at 0 and we're increasing every time, which means that I is always going to be greater than -6. This quit condition is never going to be met. So we infinitely loop until Replit says, hey, you're looping a lot, I'm going to error you out. So luckily, there's lots of catches built into infinite loops, so you won't blow up your computer by doing an infinite loop. But it's something to be wary of, because if you're doing an infinite loop, something somewhere went wrong. Another thing you might do is if you said, okay, if I is less than -6, notice that nothing appeared on the console. That's because we started at 0, which means that we started above -6. So the loop never even got off the ground. So if you're not careful about what you put in here, you might end up with an infinite loop, or you might end up with a loop that never runs. So just 2 common things to keep an eye out for as you get used to these loops. All right, well, that is all I have for you guys tonight. So you guys should be a lot more comfortable with control flow at this point. I've shown you quite a bit more that can be done with if-else statements. We went over truthiness, how you can use non-Boolean values like strings, to get either a truthy or a falsy value, or undefined or null or numbers. We also went over some more comparison operators and how you use those in if statements, so we can compare if, you know, X and Y are related mathematically, or if they're equal, or however. And then finally, I showed you logical operators, so we can actually combine trues and falses, in a way to create a new Boolean to have more subtle if statements. And then I also showed you else ifs in case you want to have multiple conditions that you check and code that executes dependent on that. And then finally at the end, I just showed you guys loops, which are extremely useful and allow you to have the same line of code or a slightly different bit of code run multiple times in a row. So you guys are much more dynamic programmers than you were an hour ago. And I hope you're ready to jump into the homework. But if there are any questions, I will go ahead and open up the floor to those right now. Okay, so someone is asking for a recap of let, const, and variable. So first and foremost, let is used for something that's going to have a changing value. So if we have an age variable that might increment or, well, it shouldn't decrement throughout the code, but if we have an age variable that might increase throughout the code, we would have to use let. So really, when you're thinking about if you want to use let or not, ask the question, will the value of this change? If yes, use let. If it's going to stay constant, you would want to use const. Let also has an extra feature, which is that it's scope specific. So if you ever declare a let within an if block, it won't exist by the time you're out. So generally, when you're thinking about let, you're not really thinking about the scope thing. You're more thinking about, is the value going to change or not? If the answer is yes, use let. If not, use const. So that really is the big deciding factor between let and const. Var, you generally don't want to use. It's an outdated variable keyword. It's something that existed before let and const existed. To be fair, var does have the feature that you can change it, and it exists within the scope. So if you ever wanted to have an if block and create something that changes, and then be able to access it outside of that, var would be the thing to use. But honestly, the reason that they set up the scope the way they did is because you really don't want to be doing something like this. If something is existing within the if block, it most likely should have already existed before. So hopefully that's a little bit of a clarification on the difference between let and const. Generally speaking, stick with let and const. These are the two that you want to use. And the way you decide which one to use is you ask yourself, will the value of the variable be changing? Okay, we have someone asking about a loop within a loop. So actually, that's a great question. And there's, I believe, one of your stretch exercises for tonight uses that. So you're totally welcome to have a loop within a loop. So let's say equals 0. So say you wanted to loop through the pixels on a screen. But we'll say it's an 8-bit screen because that will make for a simpler loop. So what you would do is you'd set up your first loop as expected. So I want to loop through 8 pixels. And we can even say that this is the width. So this is the X value on your screen. Next, you want to loop through, or at the same time, you also want to loop through your I value. So it's important that you use a different variable. But the loop conditions would still, if it were 8 by 8, would still look the same. If it were 8 by 16, maybe they'd look different. But the same structure. So then you could, within this, say, at pixel, we'll do X plus 2Y. Sorry, I'm doing some ugly string manipulation here. I probably should do interpolation, but whatever. Okay, I think I got that right. Cool, so this is like a 2-dimensional loop. Instead of just looping 8 times, it's looping 8 by 8 times, so actually 64 times. And it will give you, the way I've set it up, it'll log out every single combination of pixels. So if you ever want to do this kind of two-dimensional looping, you can nest loops in this way. We have a question, which is, can we count frequency of characters in a string using JavaScript? So yes, we can. I'm not going to get into how exactly to do that specific thing, but I will show you that we can loop through strings. So let's say we have, in fact, I will steal your beautiful example of a string and post it in here. So we have this wonderful string. So let's say that you wanted to figure out the frequency of characters. So maybe you wanted to figure out how many A's there are, or how many B's, or how many C's or D's. Well, you would have to loop through that string. And to do that, you would just start at 0, do less than string.length, and then you can access each character with this bracket. So if we do string at I, which is string bracket I, that'll give us a specific character. So in this way, notice we're logging all of the characters. Of course, if we wanted to do what Francis was asking about and actually count them, we would have to have some sort of variable probably up here called counter, started at 0, and then increment it every time we see an A or we see a B or whatever we're trying to count. So I'll leave that up to you guys if you want to figure out exactly how to do this. But this should help you start by showing you that you can use a loop to loop through all the characters of a string. All right, any other questions? This is the quietest you guys have ever been in the question section, which I'm hoping means that everything was crystal clear. Well, I guess we will call it for tonight then, and I'll let you guys get on to your homework. All right, thank you guys so much for sticking around and learning about control flow. So for your homework tonight, you will have 2 assignments. The first is more of a reading code type assignment where you'll see a lot of different logical operators combined together, and it's your job to figure out if the result is true or false. So that'll be fun. If you don't have much formal logic experience, it'll probably be a new way of thinking for you guys, but an important thing to develop and practice as a developer. The second assignment is code writing, so you'll have a chance to do a little bit with the if statements, but mostly just writing a lot of loops. So I hope you guys are ready to loop like crazy. I'm excited for all you guys to inevitably get your first infinite loop. It's like a initiation rite for new developers to have that panic moment where your infinite loop goes crazy. So that's it for tonight. Thank you guys for sticking around, and we are done for the week. So I hope you guys have a great weekend. I would encourage you to not, I think there's this tendency to feel like you need to be working on JavaScript every day of the weekend or reviewing things. And I'd actually encourage you to step away from things and really take a rest. And you'll find that these things sink in actually quite well on their own if you're not pushing them too hard. Plus, we'll do a little review on Monday. So I will see you guys next week, and good luck with the homework. Have a great night.